So in the next question, we are supposed to construct a second-order linear homogeneous ordinary differential equation with constant coefficients, such that this graph that we see is a solution of. Well, generally, the form of such a differential equation is y double prime plus by prime plus cy is 0. Well, sometimes, of course, we have a, but we just divide by a for convenience. It doesn't matter, of course. Right? Now, so what do we see in the plot? So in the plot, we see decaying oscillations. So it means that the general solution of our differential equation looks like is y equals e to the power lambda t times some coefficient of cosine of mu t and sine of mu t. Well, where the roots of the characteristic equation R1, 2 are lambda plus minus I mu. Well, if we found lambda and mu, then by Viet's formula, we can find C and B. So notice that C is actually R1 times R2, which is if you multiply lambda plus I mu times lambda minus I mu, you will get lambda square plus mu square. And B is minus R1 plus R2. And R1 plus R2 is just 2 lambda, so this is minus 2 lambda. So this is a general formula. Now, how can we find lambda and mu here? So let us first do mu. So notice that, well, actually it doesn't matter, so we can do them independently. So the quasi-period of oscillation is 2. So it means that cosine of mu t plus 2 equals cosine of mu t. While at the same time, cosine of mu t plus 2 is cosine of mu t plus 2 mu. Right? So it means that 2 mu must be a period of the original cosine. So which essentially means that 2 mu is 2 pi. So canceling here, we see that mu equals pi. So this is how can we find mu? How do we find lambda? So to find lambda, so notice that what we see here is that we need to compare the amplitude of the different oscillations. And the amplitude of the second oscillation is 3/4 times the amplitude of the first oscillation. Right? So this is 6. So the amplitude of the first oscillation is 8. Second oscillation is 6/8. So 3/4. Is 6. So which means that the second oscillation is 3/4 of the previous one, and so on. So every next oscillation is 3/4 of the previous one. So how do we write it down? Well, so it means that if we have e to the power lambda t and e to the power lambda t, so we need to substitute t corresponding to the first oscillation versus t corresponding to the second oscillation, which is 2, and do times 3/4, and we are going to get an equality. This means that e to the power 2 lambda equals 3/4. Applying logarithm, we get 2 lambda is ln of 3/4, or lambda equals 1/2 of ln of 3/4. By the way, notice that 3/4 is less than 1, so logarithm of 3/4 is negative. So lambda is negative, of course. Okay, so this is lambda. So now we have found mu and lambda. So to find A and B, B and C, well, according to these equations, B is minus 2 lambda. So this is minus 2 times 1/2 ln of 3/4. So 2 cancels out. So this is minus ln of 3/4, or ln of 403. So this is B. And C is just the sum of squares of mu and lambda. So it's going to be mu is pi square plus lambda squared. So lambda is 1/2. 1/2 squared is 1/4 times ln squared. Well, I could write ln squared of 3/4, or I could write ln square of 4/3 because so one of them is negative of the other. So when you square, it's the same thing. Okay, so this is basically the final answer. Well, if you want, we can write it as y double prime plus b is ln 4/3 times y prime plus pi square plus 1/4 ln square of 4/3. Everything times y equals 0. So this is the final answer.